Start recording. Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. Yesterday we did some work on our debug system and we got up to the point where we pretty much had done the work we would want to do except for one little part, which is about hierarchically organizing things. And we kind of came to a point where one of the other things in our debug code that was still on our list of things that needs fixing pretty much blocked us from making any progress. We definitely needed to address it before we could go any further with the thing we were doing. And it's just kind of a holdover from when we were sort of figuring out what the debug system was and how we wanted it to work. And so what we need to do is we need to kind of go back now, take a look at that code, and actually write that part of the code for real, right? We got to do a reasonable job on that piece of the code instead of kind of leaving it the way that it was. So that's what I'm going to do today. Today is day 215 on Handmade Hero, so if you want to follow along at home, please unpack day 214 source code, and you'll be exactly where I am today. So if you remember where we left things off yesterday, when we kind of run our game, you can see that mostly we're getting the debug output that we expect, but it's all done, like we're getting it many times, right? So we're seeing this kind of you know, any given line that we might look at is actually appearing lots of times, and that's obviously not at all what we want to happen. So what we would like to do is, you know, get that bug fixed. But the only reason we have that bug, it was not, I don't think, actually in the code that we wrote yesterday. I think that code is probably working mostly as it should. And so the real problem was in the fact that we still don't have a coherent story for how we're dealing with the actual state of the debug system as new frames come in and they get processed. And these frames get kind of collated and stuff like this happens. And so what we need to do is we need to sort of come back here now that we kind of know how the debug system works and what sort of stuff gets stored in it and how all that goes. We need to kind of come back here now and go, okay, wait a minute. What are we actually going to do now in terms of processing debug records as they come in, right? Like, how is that going to work? What are we going to do here? Because we need some sort of a plan, you know what I mean? To make sure that we actually store debug events, store the data that we're trying to store in a smart way, in a reasonable way, and sort of make everything you know, work correctly. So if you remember how this worked, we essentially have a table of debug values, right? And these debug values are in the like up in here. We sort of have this concept of a debug table, and what this debug table had is it had a max debug event array count, and then it had a max debug event count. And the max debug event count is how many events you could have on a frame. And the reason that we had these buffers, and the reason that they're sort of stationary buffers that just sort of sit there, is we didn't want there to be really any overhead in writing to the debug system. So we're fine with arbitrary amount of overhead kind of at the end when we go to pick up the debug events and see what they do. That's fine, but we don't want any real overhead in the streaming out of the debug events themselves, so that there's no cost for us to sort of increase the amount of debug traffic there. It's kind of like free beyond just the simple act of writing it. There's no more cost that kind of comes in there. And so what we kind of did is we made these debug events and we stored as many of them as we thought we might want in terms of how many arrays. So we've got sort of 8 copies of the debug events, which I guess would correspond to, right, like 8 frames worth of data potentially, you know, 8 sort of clicks of the debug system. And so the thing about this, when we look at it, is we have a number of, for lack of a better term, we have a number of options now that we know how things work. So we know that things stream out into this system, and we do use the data that's in the stream itself. And if we want to sort of save the amount of traffic in terms of memory traffic of copying debug events out of this array, then, you know, you could easily argue that maybe we just want to leave things in here and view them directly out of the array. But we could also equivalently argue that maybe what we would rather do is to just use these events as a temporary holding ground. There's only 2 of them, so instead of like the max debug event count being 2, I'm sorry, the max debug event array count being 8, it would be something more like 2. And then what we would do is we would have, you know, just a ping pong buffer kind of situation where we write to one while we're collating the other and collate one while we're writing to the other, right? We kind of just flip them. So we could do that, and then that would entail taking the data out and putting it into some other storage somewhere else. And there's really no difference between those two other than in the one case, it would allow us to do things like save specific frames if we wanted to, like capture that frame data if we wanted to in a more specific way. and you know, at the expense, basically, of having more memory bandwidth in that copy. Now, there's a reason that that kind of interests me. The reason that I find that to be somewhat interesting is when you take a look at how this events thing works here, right? What I want to emphasize is that even though these are split up on a frame-by-frame basis, right? And you know, if I were to draw this out for you here, you could sort of see perhaps what I'm talking about here on day 215. There we go. If I were to sort of draw this out here, what you can imagine happening, right, is there are these debug buffers, and you know we've got sort of this giant set of debug memory, and you know there's I think we said there were 8 of them, right? And then each one of them is like the max events size long, and each thread, you know, there's all these threads out here, right? And each of them is just kind of writing in here as they go, right? And they use a locked increment to ensure they don't step on each other's toes, but they just basically fill this up, okay? And then when this thing is, when we get to the point in the loop where we're about to display the frame, we latch it, we call the debug system, and we say, hey, you can advance to the next one yet. It does, again, a locked increment of the frame number to move so that all the threads start writing into this one, which leaves us with a series of, at this moment, 8 buckets, each one representing a frame's worth of data. But, it's not really a frame's worth of data. It's not a frame's worth of data because the debug system actually fires before the actual end of the frame occurs, right? So really what happens is the frame starts here, we do a bunch of work, the frame ends here, the debug system takes over and does some work and does some drawing, then some stuff happens to display the frame, and then the frame is actually displayed to the screen. And the time when the debug buffer flips is actually the time when the debug system is first called. So actually, I guess it would be more appropriately be here, right? So if you look at how these buffers work, the actual frame data is actually looks like this, right? If that makes sense. Adding to the problem, making things even more complicated, is the fact that there are events happening asynchronously here. Like, let's say we're going to load a texture off of disk or something like this, and it's like lasts this long, right? Well, we may have a timing zone or something like this that started in this frame, right? This is frame 0, but ended in frame 1. So the data for this particular event does not actually exist wholly constrained to a frame. It actually exists across more than one frame. And so again, we see sort of this problematic scenario where our frame data is not really, is not really coincident or doesn't mean the same thing as the buffer. The frames and the buffering are not really the same thing. And that's one reason why it's very appealing to me to say I would like to make this just be a temporary buffer, and I'd like to pull things out of it and put them into the permanent storage in sort of like a different way, rather than trying to keep it around like this. Now, I don't know if that's a good idea or a bad idea. Again, the increased memory traffic is a concern, certainly. There's reasons to be worried about that. But I don't know. At this moment, if I have to make the call, and I do have to make the call, I feel like what I would rather do is see this go down to 2 arrays and just an A, B array that get flopped between. And when we go to process one array, we pull everything out of it, and we copy anything that we want into our sort of permanent debug information storage. And then later, when we want to throw that information away, we can throw it away on an actual specific frame basis and not on a basis that has to do with these buffers, which are not really all that related to the actual events themselves, because events could span them or whatever. And so, yeah, it's basically just about removing one of the additional overlaps here by saying it's just a scratch buffer. And that seems like a good idea to me. Maybe I will regret that decision, I don't know, but it does seem like the kind of thing that I should look into. So my first thought is what I'd like to do is kind of stop that whole concept entirely, right? I just want to get rid of the concept that we ever actually use, the debug event stored in this array, and rather it's just a scratch buffer, and when we collate it, we are copying out the information we need and throwing away everything else, right? Everything else is gone. So let's try that. Let's just see what happens there as a start. And so in here, I'm going to say, like, we're just going to reduce this to 2, right? And then in theory, if that array is reduced to 2, our debug systems should still run, I would think. And of course, I'm already wrong, right? I don't actually see any debug information happening there. And I believe that the reason that we don't see it is because we actually would always be right at the end of things, and we had a check in there to prevent that from happening. So you can actually see we need that one extra frame to prevent the collation restarting from triggering early, right? But all that's okay, right? Because we're going to change that in a second. But you can also see that this is consistent with what we believed our bug to be. You can see how it definitely looks a lot more like what we expected it to look like here. And our debug system appears to work particularly, does appear to work correctly as well. I set the use debug to true, for example. Here's that distance. And you can kind of see now I can play with it in real time. So again, the code that we wrote for this over the past 2 days actually appears to be working quite well, right? No surprises there, and that's pretty awesome. So really, again, we're just talking about this debug storage. All right, so let's hit this a little harder then. We're going to drop it down to 2. We're going to go ahead and say, so now this thing is just a ping pong buffer, right? And in fact, max debug array event array count, we might want to get rid of now. And because I think we might want to start treating this specifically as a ping pong buffer and not a cyclical buffer at all anyway. So I'm going to take a look at what happens here. Yep, I know I'm going to get rid of that. I know I'm going to get rid of this and that and that and the. So I think I can pretty safely say this is just going to go away. And this right here, this events situation, is always going to be just something that looks like this, right? So you're always going to have an event count and events. There's always just going to be these two, and that's all there actually is in the system. Now, this part I could even say, we could take this a little bit further. We could actually say that we're just going to store an event count. That's all we're going to store. And then here in this event array, we could have something more like this. Where we just have an A and B pointer and 2 of these. I guess I don't, now that I think about it, I'm not sure. I'm not sure that actually needs to happen. That could actually be incorrect. In fact, what is event? Event count actually isn't even necessary, right? Because event array index is what stores that. So all this I think can just be simplified in its entirety. That to-do still applies, and it's not a to-do that I think we'll ever probably address. It's just a note there in case anyone's wondering why the system misbehaved in some weird corner case. They wouldn't be wondering. They could see that, like, oh, right, that's true. All right, so I think this is what we want here. I don't know where max debug event count actually is applied or what that's actually used for. It looks like it's only happening when we actually sort of do this right here. So it kind of seems like we could even use the array count there. We could just say something like array count global debug events 0, right? We could just say that's what we want to do that assertion based on, and I think that would compile just fine. At least I suspect so. And so all of this stuff, yeah, we don't care about. So I think that's all good, and that means we can now get rid of this define as well, and we can just get down to basically just like we've got an array here, happy birthday, everyone's fine, and it's great. Now we've got max debug thread count. I do not actually remember what we needed that for. I assume it was some kind of a stack thing when we were doing like checking, so I'm going to take a look and see. That doesn't even get used anymore. So it looks like we can really simplify our debug table down to something pretty nice and clean. Really the only oddity here is that there's got to be those 2 ping pong buffers. I don't think there's any way we're going to get rid of that because of the multi-threaded nature of the program, even this early in development when we are not trying to do anything too fancy with threads. We're already got, our renderer is multi-threaded and our loading system is multi-threaded. So, even just with that, we're going to want that ping pong stuff to keep us thread safe. So we're going to leave that there. And now I'm going to go ahead and start moving over to porting the rest of the code to something where we know that that event array is not actually going to be there for us to use. So everything in our debug system is going to actually use copy out. into some kind of a more sort of generic ways, permanent records, sort of free list, happy, funplex thing. It probably sounds like it's going to be a little bit of a nightmare because we've got all of these things with referencing each other and stuff, but honestly, I think it probably won't turn out to be that bad, famous last words, because the sort of scope of what it's trying to do is relatively narrow and easy to understand. We just have frames that we're buffering up, and that's not so hard. So let's take a look at what we actually might want to do here. In our debug system, I think what I'd like to do is I'd like to be able to have when our debug state, so in handmade debug.h, wherever that ended up, yeah. So in our debug state, we have a thing of frames, and I think what I'd like to do is be able to, I'd like to still have that sort of debug frames, this concept here, this like array of debug frames. I'd still like to have an array of debug frames, and I'd like to have sort of this concept that we have n frames of back storage. And so really the only thing that I want to change about that particular process is the fact that instead of these things being collated and piled up on each other, I want to, every time a new frame comes in, I want to just sort of push that data into the permanent store and like get rid of one of the frames of back storage that we have, right? Or something like that. So yeah, so we'll see how I want to do that in a little bit. But point being here, the debug frame thing here, probably I'm trying to think of how I might, I'm just not 100% certain yet exactly how I want to store those. I might want them as sort of a linked list where you, not necessarily that you actually pull out of the middle of. I'm just kind of in that way that I'm just, in my head, I'm sort of thinking it through. I'm not sure exactly what I want there. But if we take a look at this debug frame, for example, what I'm gonna do here is just, I'm just gonna have a next, and then in here I'm gonna have like, earliest frame, and then latest frame, or most recent frame. And so this will be like a pointer to the very first frame that we captured in terms of the earliest. Now, as we sort of move through the game, it'll throw frames away, so that won't be all the way back to the beginning of the game. Although maybe when X point memory comes out, we'll just store all the frames because you'll have 1 terabyte of memory in your machine or something. But at the moment, we'll just have the oldest frame, and that'll be 8 frames back, 10 frames back, 16 frames back. That could be parameterized, right? I have kind of an idea of something I want to do that we'll see that's kind of fun, that maybe makes it so that doesn't have to be parameterized anyway. But it's, don't get too ahead of ourselves. So then, on the sort of debug frame stuff, then we have the most recent frame as well. And so we'll just sort of have that as our option here. And then I'll also have one here that's like first free frame, because you know how I like my free lists. And so we'll kind of have that there. And so what I'd like to do is sort of have a system that's going to push these frames on. It's going to work like that and do its little thing. Do its little happy dance, its little happy where it dances around like a little dancer and then stops dancing because it runs out of wind-up toy energy, as all dancers must do eventually. Now, so what I want to start doing now is start peeling away sort of that stuff that was in here before for this, and you can kind of see when we do our drawings and stuff like this, when I do something like drawing the profile or stuff like that, what I want to do, instead of doing these frames this way now, I'm going to just loop through all the frames that we have. Now, that may end up actually being a bad idea. And I could include a frame count here, right, which, we already had one, obviously, but I could include a frame count here, which is basically just a thing that tells us how many of these frames we actually have, right? This collation array index and the collation frame and all that stuff, collation frame is probably still a thing that we might want to have. I don't actually know if it's one that we want to have or not, but it's probably something we want to have. And what it would be is just the frame that's not quite done yet. We haven't seen the end marker for the frame. Now there's 2 ways I could do that. Either it can be the collation frame, or it could be the most recent frame. But I think we probably want most recent frame to actually be one that we know is done, so that we're not displaying like partial frames or something like this. That's just my gut feeling. I don't actually know if that's an accurate thought or not, but that is the way that I happen to be thinking about it, right? So anyway, excuse me. If we look here at collation array index, that's going to go away, obviously, because we're going to collate these one at a time when they come in. Collate arena and collate temporary memory, I don't think we're going to need anymore because, again, those are things that we're going to do permanently. Frame bar lane count and frame bar scale and paused. You know, obviously paused is sort of more of an interaction thing and is something that we'll probably want to revisit a little bit in a bit after all this other stuff is done. But frame bar lane count and frame bar scale, to me, those seems like things that maybe should actually be on the frames themselves, potentially. But, you know, outside here, in addition to the frame count, I could see having, like, what's the maximum one we've ever seen? Because that would maybe inform the profiler. I don't really know. So maybe for now, I'll just stick them up in the frames themselves and assume that those are, like, computed per frame, right? So it'd be something more like this. Okay, so that's what I want to sort of set up here. And so I'm going to sort of try and push forward a little bit more on that. And I think, yeah, again, some of this is getting a little unwieldy here too. If you look, like there's just a lot of things happening in here. And so at some point, we probably want to organize this a little bit more and do some other things there. But, you know, again, one thing at a time. You don't want to do too many things at once, especially when you're first starting out. You don't really want to. You want to kind of make sure that you're taking steps and taking them small enough steps that you can see how they went without jeopardizing like the whole structure of your system, because you may make a wrong decision somewhere and then you've like wasted a lot of work and have to kind of unwind. So, okay, when we come through here, I can now do this iteration in a slightly different way. I can essentially say, okay, I want to start at the debug state oldest frame, and then I just want to iterate until I get to the most recent. And that's really all I have to do. That will give me the frame. I can draw the frame. And then in here, where I was looking at the debug state before, oh, well, that actually doesn't happen in here, it looks like. But I would, when the time comes to look at things like bar scales and stuff like that, I can obviously do those a little bit differently if I needed to. Okay, so frame bar lane count. So for example, here when we're doing draw profile in, like I said, so that lane count, you can see actually does get sort of used in a bunch of places here. Yeah, you can sort of see all this stuff. All of this stuff really kind of wants to be inside, probably, it looks like. Although, you know, so the thing is, it wants to do the lane count there. I don't know, I could do something like this where I just pre-step through. So I say, hey, for each of these, I guess I'm missing a semicolon there. There we go. You know, for each of these, as we go through, I want to see what the max lane count is. So I would just do something like setting the lane count, you know, to 0 or something like this. Although I don't know if we ever divide by lane count. No, we don't. We guard by it there. So as we go through here, you know, looking at the frame bar lane count, I can do sort of a max thing. I can just do like, you know, if lane count is less than whatever this frames one was, then I'll make that be the max, right? And so that way we can still do all of the same stuff we were doing. And frame bar scale, I guess probably would be the same as well. So frame bar scale, I don't really remember. I guess that's how long the thing was. Okay, so frame bar scale is just kind of nonsense here. Frame bar scale actually was set. We didn't actually ever do anything useful with that. Which is kind of unfortunate. But yeah, so frame bar scale we just want to get rid of now and replace with something a little bit better, right? Excuse me. So what we want to do with frame bar scale is the same thing, right? So here's frame bar scale. And I believe we want the minimum one, so it's the one that's going to be the smallest so that everything fits. So the frame bar scale would be something like a float max, right? Or rather, it would be something like 0. No, we want the minimum, so I'm right. It was something like the maximum value. And then basically, if frame bar scale is going to be less than whatever the frame bar scale is, then we would set them equal. And as we work on our profile rendering a bit, maybe those change a little bit later down the line. But, you know, for right now, at least this keeps some reasonable feature parity to what we had. So in here, our frame index we can still keep, right? We can still have a constant of frame index, and we can still say we know which frame we're on relative to the other ones for drawing it, and that's all fine. So what we need to do now is we just need to have some way of doing this collation out to these individual frame things instead of doing them sort of haphazardly. So the first thing that we're going to do, right, is get rid of that concept of the collation arena and actually use real allocatable values. And so when we take a look at this stuff where we're allocating the debug threads are already, I think, don't they already go back to a free store, or don't they? How did the debug threads work? I don't actually remember. Debug thread. So we do need a debug thread, right? First, a free thread. And what's interesting about this is we will have a few free lists here. This is again something that I would normally I would be generating. And if you want to do this in, there's just not enough to it. But you know how we did our dlist thing, right? We have our dlist insert, dlist init for wlink list, right? We just have that's that whole situation. We could, sort of do something where we have something like that happening. So the push struct, it would do a sort of like, can I get one from the free store? If not, do the push struct, right? But basically, first free thread would be used. If that didn't work, then it gets one from the actual debug arena. And that's it, right? So then we go ahead and fill it out, and that's all that happens. Again, nothing particularly unusual here. And we just need this to actually do our free list dequeue. So in order to do that, after we actually have this thing get pulled, we need first free thread to be whatever the thing that was after the result. Now, since we don't know if there was another one or not, like if there was actually one on there, we need to make sure that we actually dequeue it, sort of a way more like this. So basically what we're saying is, okay, give us the first free one. If there is, if that worked, then we want to advance the free list pointer. If that didn't work, then we want to allocate a new one, right? So that there shows you the pattern for dequeuing off of a free list version. Do we want to wrap that up? I don't know. It's not very much code to wrap up, but you can imagine doing something like that, right? So maybe if we want to do that, free list, alloc or something like this. And if I wanted to do this, I just need to figure out exactly what all this stuff would be. And so what we want to say is, first of all, like, what is the actual, what's the actual value that we're trying to create, right? So we have like, the value, or you could even call it result potentially. So we have the result. The result is trying to get something off of the free list pointer. So this is like the free list pointer. And so it's trying to get something off of that. Assuming that it gets it, it's going to use the next, right, to get it. If not, then it's going to do a push struct to try and get it. It needs to know the arena, and it needs to know the type of the thing that's going to be got, the thing that's going to be retrieved, right? And I think in C++ 11,000.96 revision 12, I think you can do a thing that's like decal type, right? Where you say like, oh, whatever this thing was like actually pointing to, right? Get me that thing. Of course, I didn't spell it right. And that would prevent anyone from actually having to sort of put that in there. And so a free list allocation, it just looks like this. I can make this a little more concise, like so, right? And so, again, really, really straightforward. I guess we could even do this if we're just absolutely ridiculous about everything. We could just say like, okay, this equals this thing, and whatever the result of that is, if it turns out that that's true, then we're just going to do this. Otherwise, we are going to not do that, right? And that's all there is. So yeah, if we wanted to do that, we can just macro that up and say, okay, here's our free list alloc. It just looks like this. Six of one, half dozen of the other, but you know, it should be fine. So let's see. Pointer to reference is illegal. This is probably my non-familiarity with the new C++ nonsense, but I do believe you could do it. Free list pointer is actually the thing that we want, right? First free thread. Although, wait a minute. Did I ever actually make a first free thread? I did. Okay. So yeah, so I wanted that to allocate a debug thread for me. I'm going to look up, I've literally, like, I don't even know if we've ever used this on Handmade here. I just know that it's there. So here we go. Decal type. If the argument is an unparenthesized ID expression or an unparenthesized class member, then decal type yields the type. If the argument is any expression, the value category is X value, decal type is T address, then is T address. I don't actually want it to, I mean, not address, T reference. I don't really want it to yield a T reference, though. I don't really want a reference. What? Why did they do it that way? Well, let me see what happens if I just do this. Pointer to reference is illegal. What happens if I do that? Yeah, so cannot convert one from memory to memory in a star. That's all fine. That just means that has to do that. There we go. To debug thread star. Yeah, so I mean that's what I want it to give me the decal type of is the free list pointer. So let's see, why can't I do that? Right? Why are you complaining about that, Mr. Fancy Pants? Do I have to parenthesize it? Parenthesize it? No. All right. So tell me why you don't like it. Note that if the name of an object is parenthesized, it is treated as an ordinary LVI expression, thus decal type X and decal type parentheses X are often different types. Decal types useful when declaring types that are difficult or impossible to declare using standard notation, like land-related types. Okay. Well, that's unhelpful because I just want that type. I just want you to tell me what that type is, but you don't seem to want to do that, do you? You know, if they've always got to make it complicated, the C++ people. It should just be an expression according to this. Let's see here. So do they have any time? Yeah, so I wonder if they had a different keyword for things like I want to dereference this thing. So what's type of? Let's see here. I don't want Visual Basic. Give me something I can work with here, C++. I don't really care. I mean, I'll just type it in at the end of the day. So let's find out if there's any way I can actually just get what I want, like, you know, something a little bit better. But anyway, it's type. What is it? Type ID. But that's just the runtime type information. There's got to be something, people. Come on. Like, seriously? I mean, I guess I could do this in a ridiculously roundabout way where I declare one of these. I mean, I could do this. Right? Or something like that. I guess. Oh, but I can't do the cast. Well, I don't really want to deal with this right now. This is typical C++ nonsense. That should have been easy, right? But of course, no. I'm going to have to go read the stupid spec or something to figure out how they defined that thing in such a way that it's, you know, annoying and doesn't work. But anyway, point being, I can just do something like this where we just say, like, what's the type, you know, whatever the type is. So then we just do that, right? and then our stuff will work again. Not the way I would have wanted it to work, but not really the end of the day, not really the end of the world. It's like, it's fine, right? I don't care. Okay. So now what we want to do is there's a bunch of things here that are working off of this sort of frame-based assumption, and I want to actually be able to use that there. So maybe we'll have this collation frame thing, like I said, so that anything that we used to be doing that was on the debug state itself, we're going to do on that collation frame always, right? That's just how we're going to do it. Restart collation is not going to be a thing anymore. That's just going to be what we do at startup. So we're always going to be collating, right? 24/7. We are going to be collating, right? That's just a thing that happens. And really what that's going to look like, for example, when we do debug start, right? Really what this is probably going to look like is it's going to be something here. And instead of being something called restart collation, what it's going to be is something more like, new frame, right? Or something like this. And it returns a debug frame. And what it would do is just create all of the stuff that was supposed to happen here on this guy, all the stuff that was supposed to do to create one of these new frames, right? So debug frame, let's see, debug frame results equals however we're going to get the frame. We then have our result here. Does its thing, which is none of this stuff is necessary. Where is our actual frame? And also, what are these things? So first thread, so threads in this case are probably per frame. Well, maybe not. So maybe I was wrong about the frame bar lane count. The frame bar scale is obviously per frame, but the frame bar lane count, maybe that's just how many threads there are. Meh. I'm gonna say okay. I'm gonna leave that out here. I'm gonna say that these things actually do it that way. So that's fine. So this stuff, when we actually initialize things, we'll initialize these threads or whatever we're going to do here, right? We'll just say that those things get initialized. Frame bar lane count will equal to 0. We've got first thread. We've got first free thread. First free block, all that stuff. That's all fine. We've got all of these guys. We want them initialized as well. So we've got debug state, oldest frame equals, debug state most recent frame equals debug state first free frame equals 0. I think that's what we want. And that's all there is. It's all good. Okay. So that's all fine. And then our new frame, what that's going to do is that's just going to go ahead and get the memory for a new frame, right? So that's just going to be a push struct. Again, everything comes out of the same arena now. And that's just going to give us a new debug frame. The debug frame itself has some stuff on it that we're going to initialize here. So we want to just set this stuff up. We've got, in fact, I think I might do a 0 struct on it, just clear everything, and then only initialize the things that I actually care about. I'll say for now that the frame bar scale, I don't know what the frame bar scale should be. Maybe it's 1.0 to start out with. The root group is going to have to be initialized in some way to be something. The region count and the regions, that I think, I don't know exactly what we want to do with that yet. Again, we'll find out in a second here, but I'll initialize it as well. They'll be initialized 0 automatically. Next won't do anything. And then we sort of got, well, that's about it, right? This we don't care about anymore at all. We don't care about that. This we do. And in here, when we add something onto this, we're going to need to deal with that. But until then, we don't actually have to. So when we do our root group here, this I want to create a new one of these groups. So I want to be able to do sort of a new group every time for these guys. So we have collate create variable group. So I want to do that, right? So I want to do collate create variable group. And now these don't have to be collate anymore either, right? These can all just be, we don't have to really name them collate. It's just create variable group or whatever. Create variable group. These are all just like create variable, add variable to group, right? And these are going to all happen on the debug arena now. So all of that's, unified. Again, this actually gets rid of all that stuff that we said we wanted to do-wise. All of this stuff can now happen on the debug arena, and we don't have to worry about that kind of weird nonsense anymore, which was kind of just a temporary solution to see if our stuff was working, and it was. And then we had some bugs like this one that we now have to go fix for real, and it's all good. So that's what we actually want to have happen there. Then we go down here, collate debug records. This thing is just going to have to take all of those collate ones, which I should get rid of the word collate. This is going to take those people who are doing collate stuff. It's going to change into this. We don't need the parameter for permanent anymore, so we can basically just back out that change, which again, like I said, I don't really like. And then, yeah, everything else that happens in here can always be happening on the debug arena. That's all good. And so on and so forth. Okay. All right, we don't need the collation arena anymore. That stuff is all entirely gone, and that's all good. What we do need to do, of course, is create the starting frame. So we need something like collation frame equals new frame. So we need to make an initial frame that we start with, and that's what things will get piled into at the beginning. So that's all fantastic and happy and wonderful. And then up here, where is our new frame? Yeah, up here, what we will want to do is every time we get into a situation, we'll want to do something like, or frame, or finished frame, something like that. Something like this. What we'll want to do is take that collation frame and retire it. I guess now I think about it, I probably don't need a thing that actually, I probably don't actually need that. I can probably just put it right in here. So when we do event type equals frame marker, for example, what I can do is say, okay, let's assert that the collation frame exists. And then what I'll do is I'll push that collation frame. I'll basically add that to sort of our list. This here, I don't know why we got rid of this thing, to be completely honest with you. I'm not sure why that wasn't working or why we perceived it to not be working. So we should probably re-enable this. To do Casey, can we re-enable this now? Or something like that. But yeah, once we receive this frame marker, we can increment the frame count, and we can take debug state, and we can go ahead and put onto here our oldest frame, most recent frame, that whole thing. I can just kind of move the frame onto there. So we can say, all right, basically, if we had a most recent frame, we're just going to daisy chain. If not, then we're not. Right? So in the case when we had a most recent frame, that means the most recent frame's next one is going to be this one, debug state collation frame. And in the case, excuse me. And in the case where we didn't, then what we would do is say, well, both the first, both the oldest frame and the most recent frame are going to be equal to our collation frame. So that just puts it onto that list of frames that we have. So that's, again, pretty straightforward. And what we want, and then, no matter what happens, obviously the frame count goes up, and that's fine. Again, like I said, we want to know if we can re-enable that thing. We'll think about that a little bit later. And then what we want to do is this stuff here, is again the stuff that's sort of happening. It looks like, oh, so this is actually the stuff that we actually want to do in our frame creation. But point being, so the collation frame now, we want to create a new one, right? So we want to create a new frame for collation from now on because we've retired that like previous frame, right? So in new frame, I guess we've got that we don't need. This we're doing. Begin clock. So if there was a clock to let us know when to start that begin clock, I guess that's kind of a thing here now that I think about it. So we don't know what the begin clock would be, so we kind of need to pass the begin clock in here, right? Because we don't know what that would be otherwise. So if we pass the begin clock in here, all the rest of this stuff would work properly, I believe. We'd want to leave this, I suppose, the way that it was working, and whatever. This part, I think, probably needs to get done in a little bit different way, but let's see. To do Casey, regions need to get fancier, obviously. Okay. So what we want to do here, like I said, is we want to figure out a way to get new frame to get some information there. What I was thinking is I was going to do it this way, but I think actually what I'm going to do is let that get initialized to 0, and then what I'll do is when we first come through here, right, whenever we see one of these debug frame markers, we'll assume that we're going to retire the frame. But what I'll do, in fact, anytime, just straight up, if I see an event at all, I'll just assume that that event should have a collation frame. So if the collation frame, and I'll have to make sure that we never have something that doesn't fill out its clock value, which I think we might not do in one place, which is probably a mistake, but we'll double check that. So what I want to do here is say, okay, this collation frame, if I don't have one, I want to make sure that I get one. And when I get one, because I'm doing it lazily like this, I know that I'll have a clock, right? I know that I'll have a clock value to pass it. So we'll just say the first time we ever see an event, if we don't have a frame, it becomes that becomes the new start time for that thing, right? So again, in this case, pretty easy. I can also say that in this case, the event clock is there. So that's all good. And from then on, I don't really need to do an else if collation frame here. I can just assert that we have one, because now it's a requirement that there's always a frame being collated. You can never have anything other than that state. So we'll just assert that that's fine. When we call collate debug records, what that's going to do, obviously, again, this we can sort of change the way we were looking at this entirely. Instead of this looking at collation arrays specifically, it's really just only going to ever look at one of these specific guys right here. It's going to go through the whole array and consume all the events and retire all the events, right? So what we want to do is just say, all right, here's the debug state. We just want to pass it an event count and an event array. And it's just responsible for calling that, and whoever's going to call this will have to call it with whatever the correct buffer is for it to collate at that time, and we'll just let that be an upstream issue. Right? Okay. So let's push forward a bit here. So again, when we're doing this, our frame bar lane count now no longer has to do what it's doing here anymore, because that's actually something that is set on the debug state. And lane index, frame bar lane count. In here, yep, this is actually how that's working. Anytime it has to grab one of these guys. This is correct. It's not actually on the collation. It's actually on the debug state itself. When we allocate debug blocks, again, now we're always doing the debug arena. You can see that this code, right, is just the same code that we have now for doing free list stuff. So here it is, free list alloc. You can kind of see it's got the same thing. Take out that free list pointer. If it's there, we advance the pointer. If it's not, we allocate. Again, it's the exact same thing. So we can, if we want to, just go ahead and say this, right? There's my free list pointer, and here is my arena. There we go. And that's all good. Oh, forgot to actually declare it. There we go. So next free is actually the value here, and so I feel like I don't actually know how I want to deal with that specifically. Probably what I would want to do, or rather, I think probably what I want to do for the free thing is do something like this. So in Handmade debug.h, I probably want it always to be called next free. So in something like debug frame, I would probably want to do something like this. Just so you can kind of see that when it's on the free list, it's using some different space, right? Well, this one doesn't actually matter. And so in this case, like for example, in this open debug block one, it could just be shadowing another thing, right? It could just be that like, okay, yeah, you know, the parent pointer or something is only, you know, we just use that space, so we don't have to make it. It doesn't need to be bigger in order to have a free pointer. The free pointer is just the thing that, you know, we use off of it or whatever, you know, something like that. So that's obviously just a pretty straightforward thing that I can kind of just do for anything that's on that list. Okay. So moving along, our free list alloc now has to be something that takes next free. But that's it. Okay, so create variable group. I don't actually remember what that actually takes. No idea. Oh, it's still got that permanent lying around. We're going to get rid of that. That's not necessary anymore. Missing an equal sign there. Frames, again, is not a thing. Obviously, that's fine. But we can still do this thing, which is to say if most recent frame, right, we can do that. So we can still do this sort of thing pretty easily. Refresh collation is not a thing that we need to do anymore, I don't think, because hopefully we'll be doing things in a little bit smarter way. Maybe not, we'll find out. Okay, so then we've got our event count. This code has to change slightly because now we're just ping-ponging. This is not the case anymore, right? So what happens now is current event array index, right? If we take a look at how this is working, current event array index, that is just ping-ponging back and forth. So current event array index is always just going to be that. It's just going to flop between 0 and 1, 0 and 1, 0 and 1, 0 and 1, right? And that's all. In here, this wrapping code does not have to work at all. That doesn't have to do anything at all, right? And yeah, and really, so really the way this stuff works too, this doesn't actually have to be a U64 anymore. It could be U32, and just the high bit could actually tell you which one you were looking for. To do Casey, this could actually be a U32 atomic now, since we only need one bit to store which array we're using. Just a little note there. Of course, that was actually true before. This could have been a U32 as well, because there was no way we were going to have so many events. We weren't going to have, you know, 24 bits worth of events anyway. And there were only 8 of these. In fact, we could have more than that. So yeah, we could have done that a while back, but we didn't. Doesn't really matter one way or the other, but point being. So we do the atomic exchange here. All of that should be fine. I don't think there's anything particularly unusual going on there. The event array index equals event array index. This thing here is whatever we got back from the atomic exchange. So this is the event array index. We could assert that event array index is less than or equal to 1, because it should either be 0 or 1. We got the event count there. And so now the event count is just what we've received here. And so, yeah, again, that is just really straightforward. Nothing weird happening here. Really, really basic stuff. So when we do after we do our debug start, what we can do is we can just call collate frame, or rather collate debug records, and we can pass that the event array indexed event array. So that's the events to do. We know how many to do, and we know that we are we, right? This doesn't have to happen anymore. Goodbye. This doesn't have to happen anymore either. So really all we can do is just say, okay, if we are not paused, then collate. Otherwise, don't collate, right? And we could actually, I would almost say let's do this in an even more hefty special purpose way there, which is to say, I'm going to make that sort of be a to-do, because what I'd rather do than that is when we retire frames, just throw the frame out so that that way any frame that wasn't done yet will still collate its stragglers even after we're paused, and we'll just throw away new frame stuff. So I think what I would rather do here, right, is when we do this and we sort of push that frame on there, I think what I'd rather do is say, okay, if we are paused, then we throw the frame out. Otherwise, then we use it, right? So it looks like that in the normal case, right? And so this would be a to-do, Casey, throw away, or I could even do it here, free frame, right? Debug state collation frame. So basically every time it finishes collation, it's just going to throw it away, but it's still kind of going in the background with that collation, if that makes sense. I think that's a reasonable thing to do. I don't necessarily know. Yeah. I think that's the right thing to do. Anyway, so here we go with free frame. That's going to be a little internal void here, free frame, that we're just going to do a assert not implemented for now, because that's the thing that we'll probably want to get to when I return. And yeah, what else we got? Debug, it's global debug table. That's what that should have been. And event array is not a member of debug table. Really? You know what? I believe you. It's called events. So, assignment within conditional expression. Oh, compiler. Well, if it's going to complain, it's going to complain. I believe these days you can silence that warning by doing that. Or not. I wanted there to be an assignment within conditional expression. That's why I put it there. Fine. Mr. Poopy Pants. Stupid poopy sauce. Poopy Pants. All right. So there's the version that you're happy about, compiler person. I hope you're generated such much better code now. Anyway, so I think that's all the busy work we had to do. But now, if I'm not mistaken, we will just grow our frames. We'll grow ad infinitum, right? We will use up all of the memory that we have in our buffer, and we'll just get to an assertion when we get too many frames, right? So it'll add to the frames, and then just halt. It'll be like, hey, I got nothing, right? I believe that's what should happen. Of course, we may have other bugs, but we'll see. Ooh, that's some copy pasta there, as you guys call it. That's not supposed to be collation frame. That's supposed to be result. There we go. That'll be handled by the zero struct. There we go. Okay, so now in theory, like I said, there we go. That's what I was studying. I was like, in theory, it should get to a point where it goes, hey, you ran out of memory. What do you want me to do about it? And that's exactly what that is right there. So all we need to do now to kind of finish this up, and I'm almost out of time. I don't know when we started, 6:17, something like that. I'm not sure. All we need to do now is a way of reclaiming some memory, right? We need a way to reclaim some of the memory. And this is the first time we've really ever done this in Handmade Hero. Because like I said, 99.99% of the time, your memory management just isn't a thing you ever think about. Once in a while it is. So this is like the first destructor style thing we will do. And you'll notice it's not even in the game code, right? It's in the debug system, which is kind of amusing. But point being, this is something where we actually want to go through and we actually want to free a thing, right? And so here in free frame, you know, and I might even make a note of it here. I might even say something like important. Casey, this actually gets freed as a set in free frame. Because like I said, so much of the time I don't actually ever get rid of things in that way. It's something that's potentially worth noting for that reason, right? So what we would need to do is have some way of freeing a frame. Regions are a little bit of annoyance here, but debug variable group is the other part that we can take a look at. So if we wanted to free a frame, how would we do it? Well, first of all, we would want to be able to put it back on our free list, certainly, right? So, you know, since it's coming from a free list, presumably we want to put it back on a free list. So we'd want a frame free list. So we'd want free list dealloc, probably something like this. And if you're going to deallocate something from the free list, that's, again, really, really straightforward. All that's going to happen there is you're going to have something like this, which is like the pointer in the free list pointer. And what you would do is you'd say, okay, the free list pointer, whatever the pointer is that you've given me, and I'd probably check it. I'd just say, okay, if the pointer, if you actually give me something non-zero, then whatever the next free value is, right, it's going to be equal to whatever's on the free list right now. And then the free list is going to be equal to the pointer. That's it, right? That's all I actually need to do to free something. And so, you know, we would free list deallocate this thing. We would put it back on the free store, right? So, what do I want to do about the rest of it, right? So it's because we still got a few more things that we need to deal with here in that guy. So root group we would need to free. So we'd need to do free variable group, and that would just be the root group that it's freeing. This is going to be debug state first free frame. And in here, you know, now what we'd want to do is do the free list allocate situation in here. Now, there's a bit of a problem with it as well. Something I don't super love, and this is a thing we could decide to sort of modify a little bit, if you will, which is we could do something like this, but I want to know when something's allocated new. Meaning I want to know I want to differentiate between something that I'm getting that was from the free list versus something that was not from the free list, if that makes sense. And so that's kind of, again, something that I may want to modify this a little bit. The way I would do that, right, is I would get rid of this part of it. And one of the nice things about that is it would mean this would go back to just being this, right? And I could do something more like this would be a little bit better, potentially, right? So this would be something more like, okay, you know, here's my debug result. And what I'm going to do is I'm going to say free list allocate whatever the free list pointer is, which would be debug state, like the first free frame. I want to allocate that, and then assuming that I don't get it, then I'll do this stuff, right? Something like this. I feel like that's what I would mostly want to do. So yeah, so the only, you know, but even now that I look at it, it's still not going to be enough. It's kind of annoying because I think I actually just want this to do its thing directly. So maybe I will just leave this because most of the time people would do it the other way. I don't know. I'll show you why it's kind of a little bit janky, just the way that you're going to want to do this, at least for the time being. But it might be something that collapses a little bit when we change the way regions work. It'll probably collapse, so I'll be okay with that. It's just a little annoying. So what we want to do here, right, is we want to be able to say, okay, debug state first free frame, right? I want to say if the result, then do this thing, you know, oops, do this thing, else do this thing, and I want to actually put stuff in the block, right? So this, if we got one off of the free list, then I want to do a zero struct, but I want to save the region pointer, right? Because I might as well just use the memory. I might as well just keep that memory, right? So what I want to do there is say, okay, you know, do a zero struct. I wish you could do clears easier in C++, like clear this thing, but not this member or whatever, because I find myself wanting to do that all the time. But anyway, debug region, where is that at? There it is. So I want to do something where I say, okay, the frame that was there, the one that we got, I want to save its regions pointer. After I zero it out, then I'm going to set its regions pointer back to the old one. Whereas in the case where I get this new one, I want to be able to do this, right? So that's, again, just kind of an annoyance. We can certainly fix it later, but that's the reality of what it's going to look like at the moment, I think. So here's our push struct. Everything else should be fine, right? So that's how that would work. And all we would really need to do now is work on our variable groups, how those are getting freed, right? So let's take a look at this. In here, did I reorganize this? What did I do there? What did I end up doing? Here we go. So we've got our free list allocate. Here we go. Free list allocate. Free variable group. So now free variable group, we've got these guys here. So free variable group obviously is going to have to be probably wait till next week because I am out of time, unfortunately. But we're mostly done. So that went a lot quicker than I thought it was going to. I thought it was going to take a much longer time, but it didn't. So we're getting there. We're definitely getting there. But for right now, you would not be able to actually still quite get there, like I said, because this will hit that assertion. As soon as it gets enough memory, it's going to hit that assertion, right? So we're almost there. We will take a look at that when we come back from break. It's more or less done. It just needs a little bit more love to sort of get across that finish line. Also, we would need to, when we're doing the collation, we need to like do the trigger for this. So like to do also remember to trigger freeing frames during arena pushes. All right, so I think that's roughly it. Let's still go to a Q&A. What I would like to do, just to make sure that people who are playing around at home, who want to play with some other parts of source code, don't have to deal with the fact that our debug system is kind of still in flux. What we can do is go to Handmade debug interface, and we can make sure that this stuff can be compiled out, right? So what we can do in here is say, like, all right, let's update our macros to make sure that building out works okay. So if we look at Handmade internal, if I just get rid of that, we should be able to sort of clean this stuff up, right? And this shouldn't be defined. It should just be that, right? Yeah. So what's happening here? Debug ID is what? Syntax error missing something. Yes, that's true. Okay. And so that compiles all our debug code out. And so then we're just back to our super speedy, nice little software rendered world here, and everybody's happy, right? So that's all good. So let's just make sure that that's that way. And now we can sort of go to the Q&A and leave it for next week. I mean, 2 weeks from now. Yeah, so I'm pretty happy with that. That went pretty quickly. We'll be done with that. I mean, another hour and we'd be completely done. And then, you know, we'd have a pretty nice debug collation. It wouldn't be taking any extra time per frame too, because we'd only be doing just that one frame, so it should probably run pretty nicely, I would think. But yeah, we have to do the copy outs as well. So we'll yeah, we're getting there. Any questions? So that's good. Everyone is totally done. Everywhere. Once collation is done, will we get hierarchies going next? Yeah, hierarchies really is really easy because we already implemented all the stuff for hierarchies. All we have to do is just do the little search for the string. It's really just the string search is all it is. So that's really trivial. This is the hard work, is making sure that all the collation stuff is now is working in a sort of a permanent memory cycling way. So, any programming questions? Do we have any programming questions? It does not look like we do. Quartertron, are you going to do some tricks for compile time string searches? I don't think so. What do you mean, Quartertron? Graga, the last work I worked at, you would fail a code review miserably right now. How do you feel about those practices? I find that the more overbearing a company tends to be at code review, the more ridiculously terrible their software seems to be. Like, I know, like, for example, like Google is super hardcore about like having every piece of code be reviewed and everything, and their software is incredibly buggy, and it takes them forever to do anything, and like, you know, bugs and feature problems in Gmail will last, you know, years. You go on like their forums and people have been complaining about the inability to set like a calendar date for you know, 4 years or something like this. So I'm just like, you know, the proof is in the pudding. And so I would say, like, if you want me to start believing in some of these techniques that you advocate, I want to start seeing you ship quality software in a timely fashion that's performant. And they do none of those things, at least most of the places that I've seen that are very rigorous about code reviews, while at the same time, a lot of places I know that are not rigorous about code reviews, like video game developers, ship things that are vastly more performant, that ship every year, that are completely different every year. And I'm just like, okay, what's the deal? Like where there's a disconnect here. You know, it looks to, from the outside perspective, what it would look like is that people who do code reviews ship worse software at a slower rate with more bugs. And so I'm just like, I don't know how to, and it's less complex software as well, which is interesting, right? So I don't know. That doesn't really say anything about code reviews. You know, maybe they're actually great and it's something else about the two, but code reviews have just not looked particularly great to me. And, you know, I think they have a place. Even, you know, I even might sometimes, if I really wanted to ask someone about a particular thing that I was working on, you know, maybe I would want them to review it. I could see, you know, having a second pair of eyes on a problem can be pretty useful. But systemic code reviews are pretty useless, in my opinion. Brutal BK, do you use SQL? And if so, how do you structure your databases? I mean, I have used SQL. I'm not sure what you mean by how do you structure your databases. That's a pretty open-ended question. Quartertron, I imagine that all the paths will be known at compile time, so you probably don't need to do a stir comp, but I'm not sure if just using the addresses would work. No, we'll have to do a stir comp because the addresses will change when when the executable reloads and stuff like that. So we will have to do some of that. And we also need to parse. We need to parse the paths to line things up inside. To line things up like inside of the hierarchy, because we use like underscores to indicate hierarchy stuff. So we need to parse that. Easy sign. By the way, I tried decal type on Clang and it worked in the same kind of context. I think CL is probably broken. That may be true. Wouldn't be the first time. Clang is usually way more flexible than CL. Case V, can you give us some programming challenges for until you get back? So I'm pretty sure I've said this before, and if you haven't done it already, this would be definitely one to do. In the renderer, there's a draw rectangle function that we never optimized, right? It's just a solid filled rectangle. SIMD optimize that. Time it, find out how long it takes, SIMD optimize it, see how fast you can get it compared to where it started. That would be like a really good one to do, right? Would it be viable to write a game that uses a database model and its logic as database transformations? I have done that before, actually. I do not recommend it. Databases have some pretty severe problems that make them not particularly suitable for the things that games typically want to do. They are actually the same reasons that databases are bad for a lot of things. And you typically put up with the fact that databases are bad at those things because databases have certain other things that you want. They have like strong sequencing and there's a number of things. I won't go into why databases are good for certain things, but point being, fault tolerance, blah blah blah. Point being, databases, while they do work for some very simple stuff, the graph, like the connectivity nature of most gaming data, makes it so that databases are a pretty poor fit, since databases, traditionally relational databases, have a very hard time with graph theoretic operations. And so the kinds of things that games might do, like A star and these sorts of things, where they're searching spaces, databases tend to break down pretty hard there. And so when you're talking about using a database for something like a game, if you're not just talking about something that stores basic backend information like people's scores or the results of matches, which you can totally do, right? Like that's fine. Databases are made for that. It's great. If you're talking about something richer, like the actual game logic itself, you typically are talking about looking at more post-SQL, for lack of a better term, database technology, meaning you'd be looking at more avant-garde stuff. SQL is the old school, basic data row kind of stuff, if that's what, you know what I mean. Rows and columns relations kind of thing. And that just doesn't handle graphs the way you want it to. And you know there's plenty of database research on graph theoretic sorts of stuff, and that would be, you know, I would say that if you were going to try and do something like that, you'd be talking more about that sort of more modern branch, and not sort of the older like calcified SQL stuff, because that's just not going to fly. Martin Cohen, my mind cannot stop thinking about the scratch memory thing you talked with John the other day on the pre-stream. I'm sorry if this is a little off topic. It was a piece of memory that is kept per thread and grows a little. Do I understand it correctly that you're passing it down the call stack so that each function can push and pop a piece of scratch memory from it? Yes. Basically what that is if you want to ensure that you can always work without having thread local storage, which you don't necessarily always have, although they like shared libraries, for example, can't necessarily have it, and there's a bunch of things about it. But if you're worried about thread local storage, then if you just have the first parameter to all of your functions be a context, and that context is per thread, then you can have your own like memory heap per thread, so that only when there's contention on actually getting more memory for the heap do you actually hit anything. And what I typically do is I have that buffer kind of be expandable, and it usually persists across the thread, so that, you know, it grows to the size that thread typically needs and then just stays that size and never has to be fussed with. That's a common thing I might do. It's pretty handy. I use it for a lot of stuff. Mysterious J, I've never thought about metaprogramming much before. It sounds really interesting. Do you have any recommendation for more information on it? I do not. It's a fairly obscure thing. People don't talk about it very much. I like it a lot, but it's kind of old school. It was more popular, I think, in the old days. But I like it quite a bit. Question, what happens to the particles more simplified collision detection if you at the same time hold and drag the Windows title bar? Since the game timer will be paused when the window is in the drag size message loop built into Windows. So I guess what I would say is I don't think you really care. You're just giving that as an example, like, right, this sort of thing, because I don't actually know. In fact, let me see if this is true. Oh wait, I don't have Handmade internal turned on, so I can't actually do that. So I don't actually know if we actually pass down. Yeah, we don't keep the game running during that time, it looks like, so I don't think the particles would do anything differently. But if you're asking the more general question of what happens to simplified collision detection during frame rate spikes, the answer is, yeah, they would break down, right? And so one of the things that you have to architect when you're doing stuff is, like, we don't actually have a particle system in the game. Like, I showed some basic particle system stuff, like, just as a 2-day excursion thing we did at one point. But if we were actually putting particle systems into this game, which we probably will do at some point, we would need to define what the maximum frame rate spike would be and cap our frame rates to never spike above that. You know, that's, and then you just have to make sure your algorithms work that way. Because it's very easy, it's definitely very easy to define you know, some kind of a, what's the word I'm looking for? it's easy to define some sort of a function physics-wise that will not work particularly well across frame rate spikes, and so you do have to be aware of it. Dragon Master 47, how would you abstract a math library, as in the game engine uses a v2, v3, v4 class, and you have to do graphics libs with a predefined vector class they use for rendering, but you don't want to couple your game with one of those libs? I don't use libs that make me use a vector class like that. I would immediately not use that library. Full stop. Like, if it can't take a float pointer for whatever it is, then I'm not going to use it. I think that's about it. Okay, I'm going to close down. Let's go ahead and shut things down here. Save our lovely drawing. High quality. High quality. Okay. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. We're almost finished with our debug collation. So it's too bad we're going to be off for 2 weeks, but that's just the reality of the situation. We'll pick it back up when we're done. Like I said, there's not really much left to do on that anyway, so it's, you know, it's not like we left like right in the middle of some crucial thing and it's going to page out of our brains and we're not going to know what to do. It's like, should be pretty fine because it's just some very basic stuff left. So anyway, we will be taking a 2-week break because I will not be here, so I cannot stream. So if you are trying to follow along the series, now would be a good time to catch up on any old episodes you missed. You'll have 2 long weeks to do it, and then we will be back after that. As always, if you want to follow along with the source code, you can always pre-order the game on handmadehero.org. Comes with the source code, so you can play around with it for 2 weeks while you wait. For the next episode, you can also check the tweet bot, so when you want to find out when we're coming back, you can always subscribe to that tweet bot. It'll tell you. We also have a Patreon page if you want to support the video series, and a forum site, which allows you to post questions, stuff like that. All of that good stuff. Also note that in the forum site, we've got an episode guide here that Miblo and several other people from the community have been working on. It's pretty great. It's got time, like you can go to something on it here, and it actually has like jump markers for time, so you can kind of like go to different answers to questions or things that I did on the stream. It's pretty handy. And we will soon be updating this video archive link to point probably directly there, because it's been going for a while now and it seems to be pretty high quality and pretty up to date all the time. So I think maybe it's time to get rid of the YouTube archive link and just go directly there, because it's the better way to view it for sure. So that's about it. I will see you guys in 2 weeks. Until then, take it easy, have fun programming, and I'll see you on the internet.